Hi everybody. In today's lecture we are going to study about counting principle. In that we have to study first addition principle, which is also known as sum rule. So its statement is, if one experiment E1 has m possible outcomes and another experiment E2 has n possible outcomes, then there are m plus n possible outcomes when exactly one of these experiment takes place. When exactly one of these experiment take place. Okay, so this is our general addition principle for two experiment, or in general you may state that if experiments E1, E2, E3 up to En has M1, M2 up to Mn possible outcomes respectively, then there are M1 plus M2 plus m to the base n possible outcomes when exactly one of these experiment take place. Okay, that means at a time only one experiment is going on, then there will be possibilities m1 plus m2 plus up to mn. Okay, now second is multiplication principle. Now here statement is, if one experiment E1 has n1 possibility or possible outcomes, and another experiment A2 has n2 possible outcomes, then there are m into n possible outcomes respectively, when possible outcomes when both the experiments takes place simultaneously. Okay, when there are experiments are taking simultaneously, then number of possibilities will be m into n. In general form, generally if you didn't explain it, if experiments E1, E2, E3 up to En has M1, M2, M3 up to Mn possible outcomes respectively, then there are M1 into M2 into M3 into up to Mn possible outcomes when all experiments takes place simultaneously. Okay, so in addition principle, it has exactly one of these experiments takes place at a time, and here the experiments are taking simultaneously here. Okay, so for example, if you consider suppose there are 5 roads from city A to city B and 3 roads from city B to city C. Then number of ways to go from A to C via B are. Now here we have to find the number of ways from A to C via B. Okay, so there are 5 roads from city A to B. So in solution there are 5 roads from city A to B and 3 roads from city B to C. Okay, so the total possibility to go from A to C will be here. It will be 5 into 3, which is equal to 15. Okay, so here it is given that we have to go from A to C via B. Okay, so it will carry 5 into 3, 15 is equal to 15 different ways. Sorry, 5 into 3, 15 ways to go from A to C. Okay, and in second, here it is question given that number of ways to go from A to B or B to C. Okay, here it also means that we have to go from A to B and B to C. Okay, so in this second, number of ways, so if there is a and, we have to use a multiplication. That means we have used multiplication principle, and if there is a or, then you have to use addition principle there. So here it will be 5 plus 3 is equal to 8 different ways to go from A to B or B to C, okay, which is our required solution. Next point is a permutation. Now, definition of permutation is an arrangement of a set of R elements, from set of n distinct elements is called permutation. Here in permutation we have to do an arrangement of R elements from n distinct elements, set of n distinct elements, where 0 is less than equal to R less than n. Here is a condition on R such that here it is 0 less than equal to R less than equal to n, and its notation is NPR, or it can also written as P of n comma R, okay, or it also written as NPR, okay, and its formula is NPR is equal to n factorial divided by n minus R factorial, okay, is a formula for permutation. Okay, for example, if you consider a set A, if you consider a set A is equal to 1, 2, 3, and we have to select two elements, we have to arrange two elements, so we have to use a formula P of, here in set A there are three elements, so it will be here n is equal to 3 and here R is equal to 2, so it will be 3 comma 2, so which will equal to 3 factorial upon 3 minus 2 factorial, which is equal to 3 factorial upon 1 factorial, which is equal to, value of 3 factorial is 3 into 2 into 1, and 1 factorial is 1, so it will be 6, okay. So we can arrange two elements by 6 ways, okay. Consider next example. Find total number of different photographs of 5 persons on 7 chairs. Okay, so we have a question that find the total number of different photographs of 5 persons on 7 chairs. That means we have to here find, or here in solution you may say that one person or first person may sit on any one of chair. Hence, he has 7 choice. Okay, that means if you consider first person and there are 7 chairs, so it will have 7 chances to sit, okay, on which he want to sit. Okay, for second person it will be here if first person is sitting on one chair, so here it will remain, it will, for second person it will have a 6 choices. So second person may sit on any one of chair, remaining chair, any one of a remaining chair, hence he has 6 choices. So for third it will have 5 choice. Okay, so for fourth person it will have 4 choices. For second, third it has 5 choices. For fourth it has 4 choices, and for fifth person it will have 3 choices. So the total number of arrangements are, we have to arrange this into, so it will be 7 into 6 into 5 into 4 into 3, and its total multiplication is 2520. Okay, so total number of different photographs of 5 persons on 7 chairs will be 2520, or you may directly solve it by p7 comma 5, or it also written as 7p5 is equal to 7 factorial upon 5 minus 2 factorial. Okay, sorry, 7 minus 5 factorial, n minus r, which is equal to 7 factorial divided by 2 factorial, which is 7 into 6 into 5 into 4 into 3 into 2, and divided by into 1, which is 2 into 1. 2 will get cancelled, and multiplication of this will gives 2520 different photographs. Okay, so which is our required solution. When arrangement is given, or we have to find different types of these examples, so we have to use a permutation. Next example is, there are 7 rooms and 4 of them to be assigned to 4 programmers as office, and use the remaining 3 rooms for computer terminals. Find the number of different allotment possibles. So in question it is given that there are 7 rooms and 4 of them to be assigned to 4 programmers as an office, and use the remaining 3 rooms for computer terminals. Full stop. Find the number of different allotment possible. Okay, so in that, first we fix here 3 rooms for computer terminals. 3 computer terminals out of 7 rooms in 7C3 ways. Okay, here it is a selection. we have selected, so it is for of combination. We will define combinations also. So here there will be, we have to select 3 rooms from 7 here, so it will have 7C3 ways, and remaining as a office for programmer, and remaining as office for programmer. Okay, now that is, we have 4 offices. In question it is given that 4 programmers as a office, so 4 offices can arrange for 4 programmers, that is, or in 4P4 ways, because there are we have fixed 3 computer terminals in 3 rooms, so there will be 4 remaining rooms, and we have 4 officers, so it will be 4P4 ways. Okay, so total allotment or total number of different allotment or total allotment can be made in 7C3 into 4P4 ways. That is, a formula for 7C3 is 7 factorial upon 7 minus 3 factorial into 3 factorial multiplied by 4P4 means 4 factorial upon 4 minus 4 factorial, which is equal to, or here I will write 7 factorial is 7 into 6 into 5 into 4 factorial divided by, here 7 minus 3 is a 4 factorial into 3 factorial is 3 into 2 into 1. Here 4 factorial will get cancelled, and here 4 factorial upon 0 factorial, which will give us 4 factorial again. So total calculation will give us here 4 factorial, which here 3 ones are 2s are 2 ones are 2 cancel, so 7 5s are 35 into value of 4 factorial is 4 into 3 into 2, which is 4 3s are 12 into 24. So after doing total calculation, it will give 840 ways. Okay, which is our required solution. Okay, now we see the definition of combination. Definition of combination is a selection of elements of a set is called combination. Is called a combination of elements, and it is denoted by, or it may be defined as, it is defined as a selection of R elements, a selection of a set of R elements from a set of n distinct elements is called combination. And here where 0 less than equal to R less than equal to n is a condition on R, and it is denoted as NCR, or C into bracket n comma R, and which is equal to, formula is n factorial upon R factorial into n minus R factorial. Okay, which is a formula for combinations. So for today we will stop here. In next lecture we will see about examples related to combinations.